This video will show you how to create a property diagram with stepping and temperature in the iron-carbon system using the graphical mode of Thermo-Calc. The calculation is based on example number 2 of the examples listed on our website. However, this video will show you how to build the calculation so that you can customize it by selecting your database, configurations, and settings. If you want to learn how to use the examples as they are on our website, view the video How to Use Examples. To begin, open Thermo-Calc in the graphical mode. The easiest way to create a step calculation is to use the property diagram template. Simply click on the property diagram button, and all the nodes will appear in the project pane. You can also add the nodes manually by right-clicking on the bottom node, hovering over Create New Activity, and adding them one at a time. Once you have your nodes, you must configure each one. Start by selecting the System Definer. Here we'll select our database and elements. Click on the Database drop-down menu and select the FE Demo database. If you're using an older version of Thermo-Calc, use the pturn database. And if you're doing your own calculation, select the database you need. Next, I'll select the elements iron and carbon. The system is now defined, so click on the equilibrium calculator to set the conditions. We need to set temperature, pressure, system size, and composition. Based on the example, the temperature will be varied between 500 and 2000 Kelvin, so we'll set it to 1000 Kelvin here and set the range later. For pressure, we'll use the default value of 100,000 Pascal, and the system size is 1 mole. For the composition, we only need to set one element because the system size has been defined, making the other element dependent. Therefore, when we set carbon, iron will adjust automatically. We will set carbon to 0.1 weight%. Remember, you can change these values if you're working on your own calculation. You can also change the units for temperature, pressure, and so on. And you can change the composition unit. We also need to select our calculation type, so select Property Diagram. When we do that, your temperature range will appear if it was not already there. Set the range to 500 to 2000 Kelvin. You can also step in pressure, system size, and composition. Our calculation is now configured, so select Perform Tree at the bottom center of the program. Once the calculation is complete, a plot will appear in the results pane. The x-axis shows the temperature, and the y-axis shows the amount of phases. You may notice that the temperature range does not match what we set. This is due to automatic scaling, but we can fix this by selecting Plot Renderer and unchecking the automatic scaling boxes for both axes. Let's also change the maximum temperature back to 2000 Kelvin. You can also change the y-axis to show a variety of things, such as Gibbs energy. We'll leave it on amount of phase. Now click Perform again. This plot shows you how the fractions of stable phases vary for an iron 0.1 mass% carbon alloy when the temperature is varied between 500 and 2000 Kelvin. For instance, at 750 Kelvin, there are two phases, graphite and BCC. If you zoom into the graph by dragging the mouse down and to the right, then hover over the line representing graphite at 750 Kelvin, you can see that at this temperature, graphite makes up roughly 0.46 mole% of the system. Now zoom out by dragging up and to the left anywhere on the plot, then zoom in on BCC at around 750 Kelvin. You can see that BCC makes up the other roughly 99.5 mole%, totaling 100%. This type of calculation also allows you to see the phase transformation temperature. For instance, we can see liquidus is roughly 1800 Kelvin in this example. You can also see these results in the form of a table. Right-click on the equilibrium calculator, hover over Create New Successor, and select Table Renderer. Then select Perform. A table will appear in the results pane. If we scroll to 750 Kelvin, we get similar but more precise results of the percentages we looked at earlier. Notice that there is still a tab with your plot. You can export the contents of either the table or plot in various formats by right-clicking on either and selecting Save As. You can go back and change the configurations at any time to run a new calculation. You can also add additional equilibrium calculators and table and plot renderers if you want to create additional calculations. Each calculation will receive its own tab in the results pane. You can save the entire project to return to it later or share it with others by clicking File, Save Project As. We hope you find this example useful. We're constantly working to create new examples, so check back regularly for new files at www.thermocalc.com.